In 3, it says a student is given a standard galvanic cell represented above that has a copper electrode and a tin electrode. As current flows through the cell, the student determines that the copper electrode increases in mass and the tin electrode decreases in mass. Identify the electrode at which oxidation is occurring. Explain your reasoning based on the student's observation. Okay. Well, I know that tin, since tin is losing mass, then it's going to be oxidized because those tin atoms are becoming Sn2+. So that would be the explanation I would give, not their second one, but you can use their second one if you did use it. As the mass of tin electrode decreases, where does the mass go? Well, it becomes tin ions in solution, so you get 1 point for that as well. In C, it says in the expanded view of the center portion of the salt bridge shown in the diagram below, draw and label a particle view of what occurs in the salt bridge as the cell begins to operate. Omit solvent molecules and use arrows to show the movement of particles. So you want the potassium and nitrate. So potassium is going to move towards the copper side, since copper is forming, the copper 2+ ions are forming solid copper, so you're losing positive charge in that solution. So K+ is going to go towards the left, while NO3- is going to go towards the right, towards the tin side, since you're forming tin ions, and so to balance the charge you need those. So potassium to the left, nitrate to the right, and you get 1 point for the correct representation of K+ and NO3-, making sure just to show K+ and NO3-, and then 1 point for the correct direction of the movement. So you get 2 points for that, which is really nice. In D, it says a non-standard cell is made by replacing the 1.0 molar solutions of copper nitrate and tin nitrate in the standard cell with a 0.5 molar solution of copper nitrate and tin nitrate. The volumes of the solutions are identical to those in the standard cell. Is the cell potential of a non-standard cell greater than, less than, or equal to the cell potential of the standard cell? Justify your answer. Okay? Well, if you decrease the concentration of both tin ions and copper ions, your Q is going to stay the same because you're decreasing the concentration of product and reactant at the same time. So even though their concentrations decrease, since they are equal to each other, your Q doesn't change, and therefore it's going to stay the same. So you get 1 point for the correct answer with justification. In II, it says both the standard and non-standard cells can be used to power an electronic device. Would the non-standard cell power the device for the same time, a longer time, or a shorter time? Well, the non-standard cell has a lower concentration of copper ions, which are your reactants. Therefore, you're going to run out of copper ions more quickly, and therefore it's going to power the device for less time. So that would be my explanation. They have another explanation there which you can use, but I would have done the first one, so you get 1 point for that. In E, it says in another experiment, the student places a new tin electrode into a fresher solution of 1 molar copper nitrate. Using the information from the table above, write a net ionic equation for the reaction between the tin electrode and copper solution that would be thermodynamically favorable. Justify that the reaction is thermodynamically favored. So what you're going to write is copper 2+ plus tin produces copper plus Sn2+. Then you're going to find your cell potential. And when you find your cell potential, remember, since tin is being oxidized, you've got to flip its cell potential and make it positive. So it's going to be positive 0.14 now instead of negative 0.14. And since your cell potential is positive, that means that it's thermodynamically favorable, or it's spontaneous. Or they would also accept saying that the cell observations from earlier parts of the questions are evidence that tin is oxidized and copper is reduced without any sort of outside influence, and therefore E, your cell potential is positive. But I would have given those numbers. I would have done the first explanation. So you get 1 point for the correct net ionic and 1 point for the correct justification. In II, it says calculate the value of delta G. So we know our cell potential. We know that 2 electrons are going to be transferred, so it's going to be 2 times Faraday's constant times your cell potential. Keep in mind that's going to be in joules per mole. So you can say negative 93,000 joules per mole, or you can say negative 93 kilojoules per mole, or just negative 93 kilojoules. So you get 1 point for the correct number of electrons and 1 point for the correct answer with the correct unit. So I would have put kilojoules per mole. If you didn't, that's fine. Do it in the future, but otherwise kilojoules is fine.